Welcome, everybody. Thank you for joining Women in AI Toronto Masterclass series. This is the first of the 3 language intelligent masterclasses we have lined up for July to unleash AI's potential. We have 2 more sessions coming up, and please do remember to sign up for those as well. My name is Nammi Sriharan. I'm the city lead for Women in AI Toronto. I'm also an executive coach and founder of iResilient Coach, with a commitment to empowering individuals of marginalized background, finding their true potential by overcoming challenges and breaking barriers to achieve their goal. I'm always happy to connect and support, so feel free to connect if necessary. Women in AI is a global network of female experts and professionals in the field of artificial intelligence, working towards gender-inclusive AI that benefits a global society of 10,000 members across 140 countries. Founded in 2020 in Canada, we represented in 7 cities across Canada with over 6,000 followers in our social media. We have organized over 50 successful virtual and in-person events so far. Our mission is to close the gender gap in the field of AI by educating the next generation of female leaders in AI to inclusive female representation and participation in AI. Today's session is moderated by one of our Women in AI volunteer, Prakriti. Prakriti is currently serving as a data science manager at Scotiabank, specializing in credit risk modeling with the small business lending market. Her prior experience include being a machine learning engineer at Royal Bank of Scotland. She pursued her master's in business analytics from Rotman School of Management. Prakriti's passion lies in utilizing AI and ML for impactful and meaningful business decision with particular focus on health and finance sector. Joining in Women in AI as a volunteer this year, she is dedicated to promoting the growth and empowerment of women in data science and AI community. Over to you, Prakriti.
Thank you so much, Nammi, for the introduction. And I am so happy to see so many participants in the room already on time, which is great. So today's workshop is going to be on large language models, powering the new wave of innovation by Amir Feizpour. He is the co-founder and CEO of Aggregate Intellect, which is a smart knowledge navigator platform for R&D teams in emerging technologies like AI. Amir has built and grown a global community of AI practitioners and researchers gathered around the topics in AI research, engineering, and product development. Prior to this, Amir was an NLP product lead at Royal Bank of Canada and held a postdoctoral position at University of Oxford, conducting research on experimental quantum computing, and he also holds a PhD in physics from University of Toronto. So thank you so much, Amir, for taking out the time today, and welcome you. I think this is a very useful topic to talk about. Today, Amir will cover the introduction to language modeling and its purpose, evolution and development of large language models, exploring the concept of continuous innovation with sophisticated language models, resources available to learn and build LLM-powered applications. So yeah, lots of large language models coming up in this workshop. And I will hand it over to Amir to start with his presentation.
Thank you so much for having me. I'm excited to talk to you all today about this topic of large language models. It's been a few months now that everybody's talking about this topic, so hopefully I can help navigate that topic a little, help you navigate this topic a little, and hopefully answer any questions you have about it. I have some short presentation prepared, but I want this to be interactive. So please, my goal here is mostly to answer your questions about the topic of large language models rather than throwing a bunch of new concepts at you. Well, I will do that too, but hopefully, we can have a bit of a discussion. So please do write your questions in the chat, and the moderators are going to help me, answer as many questions as I can. But before I start, I would love to know if you could put it in the chat where you're calling in from and what your role is, and maybe a short, statement about what do you know about large language models, so that I can get a sense of the audience, and I can adjust my talk as we go, but also to warm up your fingers so that you can type questions as I go. So I'm going to get it started, but please put that in the chat so that I can take a look at it as we go. Going to share my screen quickly and move these windows out of the way. Then I'll also open the chat so that I see your responses. Okay, great. Talent acquisition, training on LLMs. Great. So keep doing that, and I'll start talking. The topic of large language models has been around for a few years now. A lot of you might have not heard about it. Some of you might have. But it's a topic that the topic of language modeling has been around for, I don't know, probably about a decade, maybe less, but it became really popular since 2016, when a language model came out called BERT. And before that, I believe it was in 2015, well, transformers came out. And these were the very first times in the history of machine learning where we started getting tools that have been very, very good at essentially modeling how language works and capturing the nuances of it. And in the past few years, the development through language models that are much better at understanding nuances of language has significantly improved, to the point that today every aunt and uncle and grandma has interacted with ChatGPT probably. So it is becoming mainstream these days, and that's probably part of the reason that we are all here today talking about this topic. So sort of the holy grail of language modeling is what I'm showing in this picture here. If we had machines capable of understanding natural language, like the way we communicate, the way I'm communicating to you right now, then we would be able to talk to these machines without necessarily having to code specifically what we want them to do. We can just talk to them and they can talk back to us. And the beauty of this is that I'm not going to say that we're not going to need developers anymore. We're still going to need them for doing, different types of job. The job of developers will probably evolve over time, but the significant improvement that is going to create is that we can just talk to machines, and machine will do what we want them to do, and then talk back to us about, whatever has happened. So sort of this example that I'm showing here is a generative image created by u.com imagine feature that I asked it to show a group of people discussing a topic where a robot is, helping them navigate that conversation. And that's exactly what we're hoping language models enable us to do. So, I'm seeing that there are a lot of, students, consultants, and other people in the space posting in the chat. So that's great. So hopefully some of these are familiar, but for any of you who are less familiar with the topic, the goal of language modeling is to give the machines a sequence of words, for example, the way we speak, and have them become really good at predicting what comes next. Like if I say, I'm a computer science student, and I'm just reading from one of the comments in the chat, we want to teach machines to be able to predict what could come after that and that was the last word in that sequence of words, right? And of course, this is going to be statistical. It could have many different types of predictions. It really depends on the context, et cetera, but ultimately that's what we're hoping to do. And of course, as you can imagine, this is not only about natural language, you can do the same with programming language. So, for example, the same way that some of you might have talked to ChatGPT, asking it to write code for you, formal languages, programming languages follow the same type of logic. Essentially, they are sequences of terms and statements that lead into something bigger. And if you train language models, in other words, if you show them a statement that says, from matplotlib import, it's going to have some guesses about what you're trying to import, and you can predict that. And depending on the context, it might even actually be what you had in mind. So that's language modeling. Now, what does a large language model mean? So obviously, we are all interested in creating models that are capable of doing many interesting things. So over the past many years, we've been increasingly, enhancing the capacity and size of the models, the neural networks that become our language models. And since about, I don't know, probably 3 years ago, we started having language models that are so large, several billion parameters, like the model behind ChatGPT is 175 billion parameters, for example, that is capable of really being trained on the whole internet, on the whole text that exists on the internet, regardless of what that text is about. And it has so much capacity that can really well remember and memorize all of that, and then regurgitate it back to us, right? So, and the way these works, as I said, is largely that we train them really well in predicting what the next word in a sequence would be. There's a whole topic around the differences between words and tokens, but for all intents and purposes, let's say there are a sequence of symbols, and the language model gets really good at predicting what's next. An interesting thing that happened in that space was that as we increased the size of these models, they started becoming multitask, which means that not only they were able to do this next word prediction, but they started becoming capable of predicting other things. Since they were seeing so much data, since they had so much capacity, for example, we started saying that you could just ask it to do something that might not even be explicitly in the data set, but it has seen so many examples that it can just do that. Like you can, for example, say, I feel sick today, and you can say, what's the sentiment of I feel sick today? And probably it would respond by saying negative, right? Like you did not explicitly train it to do that task, but it has so much text on the internet that is capable of associating the statement, I feel sick today, with a negative sentiment. So that multitask behavior is a very significant landmark of what large language models were started being able to do. And a lot of the things that I'm going to show you today are related to this multitask behavior. Models that are about 5 to 20 billion parameters or larger, generally speaking, it depends on nuances, but generally speaking, demonstrate that behavior, that you just train them on the next token prediction, but they are capable of doing a lot of other linguistic tasks. I'm going to pause here, make sure that I still have everybody with me. Is there any questions from the chat that I can look at? All right. I feel like everybody is still introducing themselves. That's great. Please keep doing that. And if you have questions, please put them on the chat. All right. So I'm going to start moving through the presentation. And if you have questions, please put them in the chat. So a topic that is very, very dear to my heart is the topic of knowledge ops. It's a topic that it's a concept that I'm trying to push, because I feel like one of the very, very important things that large language models allow us to do is this concept of knowledge ops. So where does knowledge ops comes from? A lot of you have heard of terms like DevOps, like ML ops, model ops, data ops, etc., etc. In almost all of these cases, what we are referring to is our ability to create software systems that are capable of combining whatever is the first term with operations. So for example, in case of DevOps, we are talking about combining development activities and operations, which means that we are creating automation systems that allow us to quickly do development tasks without explicitly carrying out those actions. And that comes through automation, augmentation, streamlining, and things like that. So DevOps, made a very, very significant impact on software development because it allowed people to experiment a lot faster and, get a lot of interesting ideas tested quickly, develop them and quickly have them tested and iterate on them and find more useful and interesting ideas. And then, when we started working with machine learning models and data, concepts like ML ops came up because, machine learning models were slightly different than the typical software development project. So we had to do other types of automations and streamlining and augmentation to be able to, combine machine learning and operations. So ML ops became a big thing. But now, since as I said, large language models are enabling us to do automated computation on language, which is our interface with knowledge. When we talk about language, it is a window to our brains, a window into our thoughts, a window into thoughts that we externalize and put into documents or on the internet, or on social media, et cetera, et cetera. That's really the knowledge that we have that is, communicated through language. So immediately you can start thinking about, oh, wait a minute, if we can do computations on language at a larger scale and in a very effective way, maybe we can start thinking about combining knowledge-related activities and operations that are around them. So, so that brings up this concept of knowledge ops. And as I'm showing here, I'm putting down a definition of what this means. So it is a management and optimization of an organization's knowledge assets and processes to increase efficiency and effectiveness. So what does this more specifically mean? So we are talking about knowledge assets. Knowledge assets could be things like data, could be like code, could be like tools that you use or the documentation of these tools, right? So these are normally, as a knowledge worker, as an AI engineer, as a data scientist, as a physicist, as a chemist, as a lawyer, as a knowledge worker, you work with these kind of things, like you work with documents, you work with data, you work with code, and your job as a knowledge worker is synthesizing all of this into a new creation that you're doing. So knowledge ops becomes a set of mindset and tools that allow you to more effectively use all of these different things as you do your job. So these are the assets you have available, and knowledge ops is this set of processes and tools that allow you to do that. And I will talk about how this relates to large language models in a second. And another very important thing is that, very much like DevOps, that involved not only tools and automated software and all of those good things, but it also involved a bunch of processes, right? So in DevOps, we follow agile type of processes so that we can communicate, collaborate, and manage projects better. And that's a very, very human activity in the case of DevOps and even ML ops. But in knowledge ops, even these processes start to become a little more sophisticated and streamlined and maybe even automated. I will show you a specific project where we are using large language models to facilitate communication and collaboration in our community shortly. All right, so I talked about, just to summarize what I said so far, I talked about how we started from DevOps, we moved on to model ops, but now that we have large language models, we can start talking about knowledge ops. And knowledge ops brings up, and DevOps and model ops, for those of you who are familiar, usually talk about this concept of continuous integration, continuous deployment. And now with knowledge ops, I'm adding this extra term called continuous exploration. In other words, this concept of shifting left in the context of DevOps and model ops is this process where instead of developing a bunch of things and then thinking about testing them, at the very beginning, since you have automated and streamlined tools, you set up your tests, your software tests, for example. Then you develop, then the system immediately can start testing what you developed. And since you can do that, you can iterate much faster. Now you're using the same concept of shifting left to go further left into the steps that require you to explore knowledge ideas, plan those ideas, even code them and experiment with them, et cetera, et cetera. So this concept of continuous exploration, in my mind, is going to be added to continuous integration and deployment to create this concept of knowledge ops. This might be a little too fast, but hopefully you can ask questions if I can clarify anything. But if you're familiar with these concepts, the extension to this should not be too hard to imagine. But I will show you also this graph, hopefully to extend it a little more. So essentially, the way most projects work is that there are some data that you're monitoring. Normally, you interpret that data, you explore how the data can be used for the project that you have. So this is a divergent process where you're looking at all the options you have. Then you essentially converge to a plan, you implement that plan, you use the data to model, to create models, you verify your models, you package them, release them, configure them. And hopefully, if you've done it right, you have a closed feedback loop, which means that whatever you deployed will be monitored to give you more data. And using that data, you can again interpret, explore, negotiate, et cetera, et cetera. So this is like a very iterative process to build, sophisticated software products. Like this part is what we call DevOps. This whole part is what we call model ops, where ML ops is a specific case. But now that I'm talking about knowledge ops, I'm saying that even these parts that are traditionally very manual and very human can be handled using large language models. And if these can be completely automated, which I think it's going to take a while, but then you can imagine that this whole process becomes completely automated. It is like a 24/7 grad student or a software developer that can come up with ideas, implement them, test them, interpret the results, and iterate until it gets to some interesting results. And there are some projects that are currently doing that, including our project. But getting to automation is probably going to be challenging and probably a little risky. But at least we can significantly augment these steps of these very manual steps to improve the quality of ideas that we plan and implement and iterate on. Again, I know some of these are probably new concepts for you. So if you have questions, please put them in the chat. What I described here is what we generally speak about as thinking, right? Like you look at some results you have, you interpret those results, explore and negotiate, and continue iterating on your project. So this is like essentially thinking, right? So what are the components of thinking? So it is language skills, because you probably have to, in the exploration stage specifically, you have to, for example, read a bunch of documents to figure out, what your options are. And then you do reasoning, which means that out of the options that are available to you that you found through reading or talking to your colleagues, you reason which of these approaches are going to be useful for you. And then once you do that reasoning, you're going to have to use tools, and tools could be like coding, or could be like Google search, or any sort of analytics tools that you use. And using the combination of these three activities, these are like very broad set of activities. They all obviously have a lot of nuances, but using these three activities, you can quote unquote think through a problem and come up with a solution, and then use the tools to implement it. And the remarkable thing that has happened in the past, probably 2 years, is that large language models, because of the multitask behavior, have become capable of, handling these activities. So remember that large language models are usually trained on the task of language modeling, which is predicting the next token, which is pretty much the first one. So language skills is what you expect to happen. But they also have some level of reasoning skills. It's not complete, but there's some level of reasoning skills. And you can imagine this existing because they're trained on the whole internet. And there are a lot of documents that reason through different problems. So if the model is trained on predicting what text would come next, you could imagine that, in a very naive and brute force way, it's going to be able to reason through problems, especially if prompted correctly, right? So it's not something that we explicitly trained it to do, but it can do that because there is so many documents on the internet that do reasoning. It does not mean that it can do reliable reasoning unless the type of reasoning it is doing is something that frequently has happened on the internet and the model has seen it and knows how to follow that. And probably with diverse enough data set that it can understand the nuances, but it does have that capability. And with a bit of a structure around how we prompt these large language models, they can definitely do a decent job at reasoning. They're not perfect, but they can do a decent job. And finally, tool use is a very interesting one. And that comes back to what I said earlier, which is the similarities between natural language and formal language programming languages. So the interesting thing about the internet is that it has so much code on GitHub or similar, technical documentations that are combined with, natural language comments, right? Like if you look at documentations of a lot of different technical tools, they explain a bunch of things and then they write the corresponding code and then explain a bunch of things and write the corresponding code. You've seen that on a Stack Overflow as well. So you could imagine the large language model could learn how to translate between natural language and formal language. And if we can tell the model to do something and it can translate that into code, then the code, in a lot of cases, is the facilitator of our interaction with tools. Because, for example, if the large language model can translate what I'm telling it into an API call, and that API call can do any type of task, any type of information that I need. For example, it can do a weather forecast using a physics model, or it can do a mathematical calculation using Wolfram Alpha, or it could call my, market time series analysis model and get predictions for the next week or whatever, right? So if I can say that in natural language and the large language model can translate it into code and use that code to call an API to get that information and bring it back, then I have a complete set of tools because I can have the large language model explore options, reason through them, and call the right tools to get that information for me. And then use the language skills to articulate that back to me. Hopefully this makes sense. Again, if there are questions, happy to go through them. All right, I let the moderator tell me when to answer the questions. I'm going to keep going. Or do you want me to take these now?
Yeah, for sure. I mean, thank you so much, first of all, Amir. Like, this was really insightful. Like, for me, like, I also have like a background in NLP in my previous job, but like I focused a lot on the existing tools and technologies and built everything from scratch. But like I think this upcoming platform that you are generating at your company, it's very useful because it's not just combining, as you said, model and data ops, but it's also like taking care of the knowledge ops, which like for me personally, I've never heard of that. So I think it's very innovative for sure. And yeah, I mean, like the three things that you talked about, right? Like interpret, explore, and negotiate. I think that is something that we all take for granted as well. Sometimes, like we do it like manually, and we take a lot of time doing it. So just automating the whole process is also something which is like new and upcoming. So yeah, really appreciate you sharing the whole package which your team is developing. Um, yeah, and I think so. There are some questions in the chat. Nammi, would you like me to start off with the questions or?
Yeah, I think we could take these two questions and then I'll let Amir finish his presentation.
Okay, so the first question is asking, what do we mean by large language models? So generally speaking, a lot of large language models fall into the transformers category. So the examples that are in the chat are, BERT, Roberta, GPT, all of these are transformer-based language models. There's an ongoing debate around what size of model do we consider large. I don't think there is a good and agreed upon answer. But, as I briefly said at some point, I personally think that models that are more than 5 to 20 billion parameters are usually large language models. So the model behind ChatGPT is a large language model. And I think the question also starts by talking about there are several tasks in NLP. And I think that's exactly the transition point. Smaller models like BERT and Roberta can be trained on any of these individual tasks like summarization, question answering, translation, and perform pretty well on that one task. But a BERT model or a Roberta model trained on summarization normally is not very good at translation. However, a large language model like GPT-3.5, which is the back end of ChatGPT, is just simply trained on predicting the next token. It's never trained on summarization, question answering, or translation, but it can do those tasks. So, whatever is that arbitrarily transition point from which models go from single task to multitask by just being trained only once, I think they become large language models. But again, that's a very hotly debated topic as well. I don't think anybody has a good answer for it. The next question is, everyone has their own style of writing. How does that work? That's a very good point. Actually, large language models are very good at imitating writing styles. I don't know if you've tried this, but in ChatGPT, you can say, write this email in a style of Shakespeare, right? Or you could say, write this email in a style, or write a blog post about large language models in a style of Barack Obama, right? It generally is very good at doing that. So I'm going to expand that question a bit because that's one of the topics that I'm very interested in. So if you think about language, there are a few layers, right? So the style and tone of writing is the most superficial layer. Then there is the syntax of writing. Then there is the semantics relationships in writing. And then there is the common sense reasoning and other types of reasoning. Tone and style are very easy for the large language models to learn. Like, if Barack Obama usually writes things in a specific tone, the language model can pick up that tone and associate it with that person. And then if you say, write in this particular tone, it can follow that. And then when it sees many people with many different tones and styles of writing, it starts, learning the associations and taxonomy of all of these styles. So if you come along and say, when I write emails, I usually write them in a sarcastic tone. Here is an example of a sarcastic email I wrote. Rewrite this paragraph as an email in a style that I do. It's very easy for it to do normally. The next layer is syntax. So, getting grammatically correct statements. That again is relatively easy for large language models because the number of rules that exist in the syntax of a language, although it might be overwhelming for humans, but they're finite. So usually large language models are very good at writing syntactically correct sentences. Semantics becomes the thing that is a little more difficult for them because Apple, meaning the fruit or the company, is contextually meaningful only, right? Like if you're talking about markets and companies and Google and Facebook and whatever, if you're referring to Apple, probably you're referring to the company Apple. So those kind of semantic relationships become more meaningful. They're a little harder for the large language models to learn. And there are like many examples of where large language models fail at getting the right semantic relationships. The larger language models are becoming much, much better at doing that. Like, for example, if you write, Amir presented this talk at this event, period, a few more sentences, and then say, he said, whatever he said, it is easy for the large language model, for the larger language models, to understand that he refers to Amir, which is a semantic relationship that is not trivial, but these models are capable of so-called co-reference resolution. Do you know any free courses or boot camps offering training to get roles in AI? I don't know. I would suggest looking at a program called Sharpest Minds. It is a company in Toronto. And what it does is that it matches you with people who are working in industry in AI-related, data-related roles. And normally these mentors can help you answer questions like what you're asking, and with the eventual objective of finding a job in industry. And the way it works is that you share part of your first year salary with your mentor. I believe they have other models as well, but you can look at that. Other courses I haven't been keeping up to, so I don't know. But there is a lot of things on the internet. I believe the coordinators put a bunch of links in the chat that I shared with them. One of them is the link to our Slack community. And there are a lot of AI people in our community. So, if you join that community and post that question, probably people who have taken courses more recently can respond and help. But unfortunately, I haven't been looking at courses recently. Where can I find more information? Well, this topic of knowledge ops is something that I'm pushing. I'm not sure if there are a lot of formal information about it. But again, one of the links that was posted in the chat is an open book that my community is writing about large language models. And I've given 2 talks about it. You can read more about it there. But essentially, knowledge ops, in my opinion, is any automation or augmentation process that involves things that are traditionally knowledge work. So even like GitHub Copilot, in my opinion, is a knowledge ops tools, right? So there are some common pitfalls when fine-tuning pre-trained models. Any insight in healthcare applications? So they're asking, what are some of the good practices when you're trying to fine-tune these models? My personal approach to a lot of to this question, a lot of clients we're working with, this is not generally true, but in a lot of cases it is true, is that I prefer to treat, going back to this slide, I prefer to treat the large language model as essentially the linguistic interface, which means that it is the interface that understands language and generates language. Anything related to knowledge handling, which requires fine-tuning, for example, for healthcare application, like what you're talking about here, I usually prefer to do that using a small model fine-tuned on the domain knowledge, and then that model collaborates with the large language model to do a task that you're trying to do. I prefer to do it that way because the large language model will keep its multi-task behavior, and the small model gets trained on domain knowledge and becomes an expert on that domain. This is a very generic answer, and probably the answer that I tried not to give is that it depends. But really, it's a case by case thing. Another reason that I prefer that approach of training a very small model and then interface that model with the large model is that maintaining that a small model over time is significantly cheaper and easier. I know there are a lot of other nuances in healthcare. I'm not an expert in healthcare data, so I'm not going to comment on those. But there are even things like privately identifiable information or private health information that you have to think about to see how you want to redact those or handle those, etc. So healthcare data is definitely tricky. There are also, another aspect of it, which is, I said I don't have anything to say, but now I'm saying a lot of things. There's also another aspect where, healthcare information is not necessarily completely reliable, like the healthcare information that is on the internet. When you read it, even forgetting about large language models, all of the time, you arrive at the conclusions that you have cancer. I have a headache, I read a few articles and I'm like, yeah, you have a head cancer or something, right? So it's not completely reliable. So a lot of the time for healthcare related applications or medical applications, it is also important to interface them with knowledge graphs that are expert curated and verified to have reliable information and therefore doesn't hallucinate things that end up killing people or something. So anyway, does it at the core still follow the same methods of parsing the grammar based on dependency grammar, phrase structure? No, that's the beauty of these large language models, that they don't explicitly learn grammar. They just learn how to predict the next token, the next word in a sequence. And hopefully, since most of the text on the internet is written by people who knew how to write things in grammatically correct ways, the model just statistically learns that the sentence requires an article here and then needs to be followed by a singular verb and blah, blah, blah. Right. So all of the grammatical logic is learned just by statistically, significant next token prediction, rather than any sort of explicit learning of grammar. And that's the beauty of it, because this works for programming language too. Because a few years ago, the way people modeled programming languages was, as you were saying here, to extract the so-called abstract syntax tree from code and then using that to guide new code generation. But right now, that's not completely unnecessary. And that's exactly what I mean by multitask. Without you explicitly telling it what grammar is, it learns the grammar by seeing a lot of code. Or a lot of natural language on the internet. With the same token, you can imagine that it's not going to be very good at so-called low resource languages, like, I don't know, if, for example, let's say an African language that only a few tribes speak. You can imagine that there's not a lot of that on the internet. So the model is going to make a lot of mistakes in getting the grammar right. Or even like things that are higher resource but not as abundant on the internet, like even something like Farsi, my mother tongue. it makes mistakes in it. It makes semantic mistakes, it makes grammar mistakes, just because it is not as abundant as English is. So now the current momentum is about the applications of LLMs in regular business. The possibilities and capabilities of NLP are offering. So is the current application capability all about using APIs to perform the use case in hand? My question is, if it's just using these APIs, what control as a user we have to see how the model perform, execute a task, how much of optimization can we do to these APIs? Okay, so that's a very good question. So the question is saying, okay, language modeling is done by big companies like OpenAI, and they provide that to us through APIs. So is the only thing that is left for us to do to just build applications on top of this API? The generally available answer is yes. But it doesn't mean that language modeling is finished and done and nobody else has to do anything about it. There are a lot of open source projects that are trying to replicate the performance of language models that are behind closed doors like OpenAI. So there's definitely a lot of work that can be done on language modeling. Language models are, for example, GPT 3.5 is very sensitive to how you prompt it. GPT-4 is less sensitive to how you prompt it. So a lot of open source language models are sensitive to the way you prompt them. So there is still a lot of foundational work that can go into improving the performance of those. But that's usually very high resource activity in terms of knowledge and compute and data and all of those good things. So most of us end up just doing what you're saying, which is building applications on top of APIs. And the next question is, how do we monitor and improve the performance of these models through APIs? Again, since it is behind closed doors, we don't have a lot of options. Like some of these models, you can fine tune them. But as I said, my preference in the products that I design is to train small models to become experts and specialists on tasks and or data that I care about, because then I have all the control I want on top of those models, right? I can do whatever I want with it and then interface it with the large language model, because the large language model is better at natural language understanding and natural language generation, but I keep my control on top of the small model that I train. So to give you a more concrete example, instead of me explicitly writing prompts for these large language models, I can use a combination of small models to fetch some information and sort of stagger them into a prompt that is then sent to the large language model. That's a very common way that you can do this. And that gives you a lot of control over how these systems behave. But again, there could be cases where what I said is not applicable, but I yet have to see that. In your view, how prepared are organizations to leverage LLMs while protecting their private data? They are not at all. That's actually one of the very big topics that come up. And I don't think many people have good answers. There are answers that people are more comfortable with, but it doesn't mean that they are okay with it completely. I believe I provided another link to the next workshop that we're going to do. Yeah, there is a link to the next workshop you're going to do in August. That workshop is focused on the topic of business impact of large language models. And the 3 talks that we have in the morning are all focused on this question. The first one is, how do you use large language models with private data? A company called Private AI is going to talk about it because that's their area of expertise. The second talk is from Wealthsimple. They're going to talk about the governance framework that they came up with to use large language models within the confines of an enterprise. And the third talk is from Bedrock AI, which is a fintech company, and they're going to talk about okay, large language models are hot and fun and all of that, but for a lot of real world applications, the performance of small models are still better because you can fine tune them on a specific data, on a specific task you have. And if multitask behavior is not what you're interested in, then you should just focus on small models and forget about all the hype of large language models. And I love all those three topics, and I definitely invite you to join us for that talk. So that said, like a lot of bigger companies that work with cloud providers, generally speaking, are opting into using sort of sandboxes that these cloud providers are making available to enterprises. Like, clients of Azure have access to Azure OpenAI and, data within virtual private clouds and things like that, that gives them a level of confidence that their data remains private and is not shared outside of where it is supposed to. AWS has the Bedrock, I believe it is called, which is a set of foundational models you can tap into. And they also have something new in SageMaker, but I don't remember the details of it. So, big cloud providers are also giving companies sandboxes to play around with large language models without exposing their private data. Of course, like if you're super sensitive and you want everything to be on-prem and or, you're limited by regulation, for example, OSFI says, banking data cannot leave Canada, for example, then, open source language models are what people are thinking about. But again, like you really have to think carefully if you need large language models for what you're trying to do, because as much as they look like a silver bullet, they are not. So, all right. Since we have 8 minutes, I'm going to rush through the rest of this presentation. Thanks for all the questions. I love them. They're so good. So I want to give you an example of how large language models can be used using these 3 skills that I discussed to solve a complex problem. Like, let's say you are a researcher working on lung cancer and you're out in the open, running around, jogging or something, and then a question comes to mind that, can I use visual transformers to solve the problem that I'm working on, right? So instead of waiting to get home and Googling all of that or talking to ChatGPT about it, you could imagine you pull out your phone and you ask that question of your phone. So what the large language model can do, and the color coding is similar to this. So it uses the language skill and reasoning skills to interpret this question as a set of subtasks and objectives. Then it can use its reasoning skills to prioritize these tasks. And for example, this could be something like, what are the pros of using visual transformers? What are the common techniques to use to detect lung cancer? What are the nuances of medical image processing, etc. Like these could be the subtasks, right? So then it can prioritize them and say, okay, the first thing I need to look up is what visual transformers are. And then it executes that task. So it decides that within the tools that are available to me, Google search is the right tool to find this information. So it writes code to call Google search API, get the results, potentially cache it in a memory, and then use that to find some version of the answer. Then it can even use its reasoning skills to reflect on it, right? So if it finds a few different answers, it can reflect on it and say, okay, my goal was to find the pros and cons of visual transformers. In the information that I found, is that question answered or not? And if not, it can refine the tasks and redo it again. But it could also decide to use its language skills to ask the user a follow-up question. Like, for example, it can decide that it needs more information about the type of lung cancer or something like that. For example, it might ask, is the images available to you X-ray images, if that matters, or what is the format of the data you have available, etc. So then based on this feedback, this reflection, it might generate new tasks, it might prioritize these tasks, etc., etc. And this might sound too good to be true, but this is exactly what we are implementing in Aggregate Intellect, but also a bunch of projects like AutoGPT, Baby AGI, Microsoft Jarvis, etc., are exactly creating these feedback loops where a very complex problem can be delegated to machines, and in a human in the loop way, they can use information tools to gather information, synthesize it, get your feedback, reflect on it, and iterate it until you get to an answer. One project like this that we're doing in our community is that we run a lot of events, and we realize that we want to make our notes from these events available to the internet, to everybody. So we started this project where we started collecting notes from our events and put them in an open book on the GitHub. So there's a GitHub repo. I think the link is in the chat as well, that you can go to, and you can read notes from all the events that we run. And we call that an open book. But then very quickly, we realized that this book is growing really fast and nobody can sit down and read the whole thing. So we introduced this concept of Sherpa, which is a thinking companion, which follows the logic that I showed in one of the previous slides, to read that book along with other resources on the internet, and it can talk to you about information that is inside this book. So essentially, it became a live book. So it's a book that is writing itself, and you can talk to it. So this is an open source project. We are looking for contributors. If this sounds intriguing, you can join us and contribute to this project. So just to give you a quick sense of what it does. Oh, yeah, there are a lot of people contributing to it, and you are the one that we're looking for. We are missing you, so come join us. So essentially what is happening is that we have a lot of transcripts from our calls. Like, let's say this presentation that I'm giving is transcribed. Then we have written a large language model based summarizer that turns this transcript into essentially a section of the book, and then it is committed to GitHub and it becomes part of the open book. And of course, like, there are a lot of challenges we're trying to solve as we go, but very similar to the loop that I described before. This is a very, very simplified version of that. But that book, along with other resources that are relevant to our community, are being all indexed into a memory. And through Slack, anybody who wants to know anything about information in the book or other types of information available, including everything from Google, can type a question, and the system will find an answer to that question and provide it back. So this way, essentially, we have a book that is being written on its own, and people from our community can talk to that book. And some of the tasks that you can contribute to are these. One of the things that I'm very excited about is the multiplayer behavior. Like on ChatGPT, it is only you and the machine that you're talking to each other. On a Slack, anybody can contribute to a conversation, and Sherpa is just one of the one of the agents that is available. It's a third brain that is available in your conversations. Like, a few of us might be having a discussion on a Slack, and then I might ask Sherpa to find some information and add to the conversation, right? So it is this multiplayer aspect of this thinking companion in a Slack that is super, super interesting for me. And we're improving that behavior as we go. Our goal is to release this in our community in a few more weeks. But then we want to start installing this companion in some other communities and eventually make it available on a Slack marketplace. And the vision for this is to create a hive mind, because, Women in AI is a community. My community is one. There are tens of other AI-related communities, but all of these are sort of interacting in silos, in information silos. And the hope is that a bot like this can create sort of a singular knowledge base. The knowledge from all of these communities get contributed to, and then the apps in all of these Slack communities, Discord communities, etc., can fetch information from all of these different communities and share with each other. So just sort of breaking down the walls between these communities and allowing people from these different communities to interact with each other's knowledge. Here's a plug about things that we do. We also work with companies commercially. We help them use large language models in their context. So if that's your company or what you're looking for, please let me know. All my information is down here. My LinkedIn is also in the chat. So please connect with me, all of you. And that's pretty much it. Thank you for listening to me.